What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about classful subnetting concepts such as classful IP addressing, subnetting, subnet mask, and broadcast IP addresses. All right, let's talk about classful IP addressing. So classful IP addressing, this is a method that divides the IP address space for IP version 4 into 5 address classes based on the leading 4 address bits. Class A, B, and C provide unicast addresses for networks of 3 different network sizes. Class D is for multicast networking, and Class E address range that is used for future or experimental purposes. And as a refresher as to what an IP address is, an IP address is divided into 2 fields. You have the network prefix or the network ID, and you have a host ID. And what separates the network ID from the host ID depends on whether the address is class A, B, or C. So let's talk about some of the classes of IP addresses. So you have class A, and that ranges from 1 to 126. So if you see an IP address in the first octet that starts with the number 1 all the way through the number 126, you are dealing with a class A IP address, and this can support 16 million hosts on 127 different networks. Then you have class B that ranges from 128 to 191. So once again, if you see the first octet starting with the number 128 all the way through 191, you're dealing with a class B address, and that can support 65,000 hosts on 16,000 networks. And then you have class C that goes from 192 to 223, and that supports 254 hosts on 2 million networks. And then you got class D that's 224 to 239, and that's reserved for multicast groups. And then you got class E that's 240 to 255, and that's reserved for future use, research, or development purposes. But what you really need to be concerned about is just class A, B, and C. Those are the IP class ranges that you need to be most concerned about. Next, let's talk about subnetting. So subnetting, this is the strategy used to partition a single physical network into more than one smaller logical subnetwork or subnet. Subnetting allows for an organization to subdivide a large network into smaller, more efficient subnetworks to help minimize traffic and increase network speeds. Subnets are designed by accepting bits from the IP address's host part and using these bits to assign a number of small subnetworks inside the original network. And subnetting allows an organization to add subnetworks without the need to acquire a new network number from an ISP or an internet service provider. And here are some of the benefits of subnetting. It reduces network traffic by reducing the volume of broadcast. It helps to surpass the constraints in the LAN. So for example, you can surpass the maximum number of permitted hosts. And then it enables users to access a work network from their homes where there is no need to open up the complete network. Now let's talk about a subnet mask. So a subnet mask, this is a 32-bit number created by setting network bits to all ones and setting host bits to all zeros. The subnet mask splits the IP address into the network and host addresses, thereby defining which part of the IP address belongs to the network and which part belongs to the host. And you can readily identify a subnet mask because it will always start with the number 255. All right, so let's talk about the subnet mask classes. So you have class A, that is 255.0.0.0. That has 8 bits available for the network portion, which is represented by the number 255, and then 24 bits that are available for the host portion, which is the last 3 zeros. Then you have class B, that is 255.255.0.0. That's 16 bits for the network portion and 16 bits for the host portion. You have class C, that's 255.255.255.0. That's 24 bits. That's for the network ID. And then you have 8 bits for the host portion of the address. And then you have class D and E, and they are not defined. So now we're going to take all of that information that we just learned and we are going to put it all together to make it make sense. So once again, we have three main classes of IP addresses that we are dealing with when we're dealing with classful subnetting. You have class A, and those IPs start with the number 1 going all the way through the number 126. So once again, if you look at the first number in the IP address and it's between the numbers 1 and 126, you are dealing with a class A IP address. And this supports 16 million hosts on 127 different networks, and its subnet mask will be 255.0.0.0, and that subnet mask will have 8 bits available for the network portion, which is 255. And then if you convert the 255 into its binary equivalent, you will have a series of 8 ones followed by a series of 24 zeros, and the ones indicate that the bits have been turned on. And then it will also have 24 bits that are available for the host portion of the IP address, which is represented by the 0.0.0. And then you see the binary equivalent for 0.0.0, which will be represented by 8 zeros dot 24 ones following after it. Now, if you are a little bit lost and confused on how to convert from decimal to binary and binary to decimal, I suggest you guys go visit my Network Plus playlist on this YouTube channel and check out the video that comes right before this one. I give a full breakdown on how to convert from decimal to binary to hexadecimal and hexadecimal back to binary back to decimal. So go check out that video if you are lost and confused about decimal to binary conversions. And then moving on, we have class B. So once again, this is from numbers 128 to 129. So if you see an IP address that starts with the number 128 or some other number going all the way up to 191, you're dealing with a class B. And this supports 65,000 hosts on 16,000 networks. And its subnet mask is 255.255.0.0. And it has 16 bits for the network portion represented by the 255.255. And down below, you can see its binary equivalent. And then it has 16 bits for the host portion, which is represented by 0.0. And once again, down below, you can see its matching binary equivalent. And then we get to class C. This is 192 to 223, and this supports 254 hosts on 2 million networks, and its subnet mask is 255.255.255.0. It has 24 bits for the network, which is represented by the 255.255.255, and you can see its binary equivalent below, and it has 8 bits reserved for the host, which you can see its binary equivalent down below. And like I say, once again, if you are a little lost and confused on decimal to binary conversions, go click on the playlist on this channel for the Network Plus class, and then check out the video that comes right before this one. And now let's talk about a broadcast IP address. So a broadcast IP address, this is a special IP address used to transmit messages and data packets to network systems. Network admins verify successful data packet transmission via the broadcast address, and broadcast addresses are also the last IP address within a network, and it ends with .255. Another way to comprehend what a broadcast IP address is as follows. So just imagine that there is a host at a competition that is preparing to announce the winner of the competition, and they can use either one of the following approaches. The host can walk up to each contestant individually and quietly reveal the winner's name, or the host can announce the winner's name to all the contestants and then ask the winner to stand for recognition. The second option is more efficient and is essentially how broadcast addressing works in the real world. Now, as you can see on your screen here, I have provided you an example of classful subnetting to kind of explain to you guys what all of this actually means when you start looking at the numbers. All right, so let's go ahead and dissect this chart right here so we can make it all make sense as it relates to the lesson that we just got finished learning. In this chart here, you can see I have class A, class B, and class C, and I have the matching IP addresses, subnet mask, network ID, IP address range, and the broadcast IP address. Basically, this chart signifies how you would take an IP address and then break it down or subdivide it so that you can figure out which IP addresses you can assign to devices within your local network. So you're like, what the heck are you talking about? All right, so let's go through this real quick. We're dealing with a class A IP address. address. So we got the IP address of 102.168.212.226. As I told you guys earlier, 102, this represents a Class A IP address. Remember, this is the first octet. This number falls between the numbers 1 and 126. So that means we're dealing with a Class A IP address. And then I told you guys its subnet mask is going to be 255.0.0.0. The 255 represents the network ID host, and the 0.0.0 represents the actual host IP addresses. And the host IP addresses, these are the numbers that you are going to be using to assign to actual devices in your network, such as your laptop, printer, your phones, whatever it is that you got going on in your network. Now, before we can do that, we need to figure out what is the actual starting point of the network, or the network ID. And as you can see right here, I have 102.0.0.0. This is our starting point for where this IP address is going to fall within. And we figure this out by simply zeroing out the host portion from the actual IP address. Because if we come over to our subnet mask, it's telling us that we only have bits turned on that represent the first octet, and then the second, third, and fourth octets are basically all turned off or zeroed out. So we're just going to zero out all of this right here, and this is going to give us our starting point of 102.0.0.0. This is the very first IP in this network. Then we come on over to the IP address range, and this is going to go from 102.0.0.1. The .1 is the very first IP address that we can assign to a device within our network. And this is going to take us all the way out to 102.255.255.254. .254 is the last IP address that we can assign to a device within this network. And like I told you guys earlier, a Class A network, this thing can support up to 16 million hosts or 16 million IP addresses. And that's very important as it directly relates to classful subnetting. Now, there is no way in the world you're going to use up 16 million IP addresses. In the next video, I'm going to talk about classless subnetting, where you'll be able to further subdivide this into a more manageable network to meet your specific needs. But for right now, we're just dealing with the general broad overview of dealing with Class A, B, and C IP addresses. So anyways, the IP address range, this is where we are going to pull IP addresses from to assign to devices that are within our network. Now, when we get to the broadcast IP address, I told you this is the very last IP address of the entire network. So the network ID and the broadcast IP, think of these as bookends. This is the start, this is the finish, and this is where you pull all of your IPs from to assign to devices. And this is going to end in 102.255.255.255. Now, as it relates to Class B and Class C, you're essentially just going to repeat the same process over and over again. Now, being that we're dealing with a classful subnetting scheme over here, it doesn't really matter what IP address that you put up in here, you're pretty much going to get the same answers over and over and over again, because you are dealing with an entire class. So to actually use the word subnetting is really not appropriate in this sense, because this is basically as far as you can break this thing down when dealing with Class A, B, and C classful subnetting IP addresses. But like I said, in the next video, we're going to talk about classless subnetting, which will allow for us to further break these IP downs into way more smaller, much more manageable numbers to actually deal with that you might actually come across in the real world if you ever find yourself in a position where you're having to build a subnetting chart so that you can allocate IPs to devices within your network. But like I said, with this example, it doesn't really matter what IP address that you put in here. You're pretty much going to get the same answers over and over. All you're really going to be doing is just swapping out the first octet for whatever number starts off your IP address. But once again, to wrap this up, this is classful subnetting. We're dealing with Class A, B, and C, and you can identify that by looking at the first IP and figuring out exactly what class it falls in. That's going to tell you what your subnet mask is going to be. And then from there, you can proceed to figure out what your network ID is going to be by simply zeroing out the last three octets, or in this case, the last two, or in this case, the last one. And then to kick off the IP range, you're just going to add one IP to the network ID. And then to figure out what the end of the IP range is, you're simply just going to subtract one IP from the broadcast IP, because the broadcast IP address is going to end in .255. So this is going to be .254 by default. And this is where you will pick all your IPs to assign to all of your devices on the network. I know it sounds confusing, but it really isn't. But this is something that you got to know, and you're going to know it before you go out there and take this test. So with that being said, let's go ahead and do some of this outstanding check on learning. So the first question is, what is the leading octet value range for an IP version 4 address belonging to a Class B network? Is it 128 through 191, 1 through 126, 192 to 223, or 224 to 239? So which one of these represents a Class B network? And the correct answer is, it'll be 128 to 191. That will be the correct answer for a Class B network. Next question. In IP version 4 addressing, the leading octet of an IP address with the value of 1 through 126 denotes that the IP address is within the range that belongs to what? Is it Class A, B, C, or D? So 1 through 126, which class does this belong to? The correct answer is, this will be the Class A address range. Next question. Which of the following answers lists the characteristic feature of the 192.168.0.0 through 192.168.255.255 address space? So which range does this series of IP addresses belong to? And the correct answer is, we are dealing with the Class C IP range. All right. So in summary, we have talked about classful subnetting concepts such as the classful IP addressing, subnetting, subnet mask, and broadcast IP addresses. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.